So here is our first example of a topological sort, which again, remember, it's really a DFS of this graph. Also remember, we're actually storing what parents they have and also if we visited the vertice before. So there's going to be some data structures you're actually not going to see in here, just the way that this graphical representation does it. So when we start things off, just like a normal DFS, we're going to start with a scan phase and then a move phase. And then when we get to an end of something, we're going to add it to the topological order. So we'll start off at 0. We have a scan phase of 2 and 4. So we're going to go to the 2 first. There's our scan, now going to our move phase. At 2, we're going to go ahead and do a scan, and from that scan we have a 5 and a 4. So obviously we're going to look at the 4 and go ahead and move to that. That's now our move phase. Then we do our scan phase again. And notice, by the way, this is a directed graph, so this makes it much easier on the scan phase. Scan we only have to 6, if I'm not mistaken. Yep. So we're going to move to 6. And then from 6, we're going to do our scan phase. We really don't have anything. By the way, notice each time we're adding a new item as we move to the next node. We're adding it and indenting it because, as you can see, 4 called 6, 2 called 4, and then so on. So at 6, we have only really one option for the scan phase, and that's 7. We're going to go ahead and move forward. Now here's again where things get different. We're at the end of the vine. I think I used to say die at the end of the vine here. We're going to add that 7 to our topological order. And again, it's going to be a stack. So 7 is actually going to be pushed further and further down when we're all done. Now again, this is really where the parent stack and the visited stack and all that stuff really would be really helpful in this diagram. Sadly, it's not in it. But it should be there because now that we're at 7, we can't go anywhere. We're going to go back. And we only knew that 7 was, frankly, where it was called from 6 would have been that parent vector. That would have really been a big help. So at 6, we go back to our scan phase, and we've already done 7, so we can't do anything else, so we'll go back to 4. But notice, because I can't do anything else with 6, now it's placed on top of the topological order function, and again, or stack I should say, and then 7's pushed down. I go back to 4. 4 is kind of the same deal. Can't do anything about it, really. So, again, the parent stack would have been great, or parent vector would have been great, because it would have told us where it came from. But no dice. Then we put 4 on top, and now 2. Now, here's where things get interesting. We have already visited 4. We had another option with 2, and this is where the visited vector would have been great here, because 5 has not been visited yet. So, we're going to go ahead to, 5. Move to 5. There's our scan, and now moving to our move phase. We're going to add 5. Now again, notice who called it. Really, there was 2. 2 called both 4 and 5 just by this line that you would see right here. So 5, well, frankly, we go to a scan phase, and there's not a darn thing there. So we're done with 5. Add it to the topological stack, so it goes at the very top. And then we retrace, go from our 2. 2 had no other options. So let's go ahead and go back, add 2 to the top of this topological order stack. We go back to 0. And here's again where there's, I know I'm saying it a lot here, but 0 has already visited 2 and 4 has already been visited. So we don't need either one of those edges. So we're going to step forward here, and 4 has already been visited, so we don't do anything with that. And then we're done with that. But you're looking at it going, okay, let's add 0 to the top of the stack. Fine, great. But wait a minute. What about 0, 3, and 5's already been done? What about them? Well, here's where we restart things like we talked about before. So notice I didn't start at 3. I started at 1 because, again, that's the lowest value that has not been visited yet. So there's always going to be a rhyme or reason with that. And we continue with the same thing, do our scan phase. 3, 6 would be the option, but 6 has already been, we're not even checking 6 to be honest with you. We're going to check 3 because it hasn't been done yet. Go ahead and go to 3, do our move phase. Then from 3 we do a scan, but well, the only option is 5, but it's already been visited just like it says. And then we stop there. Going to add 3 eventually to the top of the topological order. and then go ahead and add our 1 since everything is done. Well, take it back. I forgot. Remember that one part said, it's not going to even look at 6. Now it looks at 6. Knows that's already been done. Can't do anything about it. So it goes ahead and throws itself on top of the topological order. And next, you'll see how this topological order will be translated into a tree. So what you see in front of you is exactly the same stack as what we had before. I'm just doing it in a program called DS so I can chart things out here. And what you're going to notice is I'm going to do this, thank goodness for video editing here. I'm going to do this in piecemeal. What I'm going to do is I'm going to connect all of these edges that you see in the graph back onto this graph as well. So I'm going to start off at 1, and you notice that 1 is connected to 3 and 1 is connected to 6. So let me show you what that looks like. So there's 1 connected to 3 and then 1 connected to 6. So my next one I'm going to try out is 3. 3 is connected only solely to 5. So let me fix that. And there that is. Let's look at the next one. I'm going to do 0 here. 0 is connected to 2 and a 4. So let me do that. And that one's done. Next I'm going to do 2. So notice I'm doing the connections from top to bottom here just to make sure I don't screw up. 2 had connections to 5 and to 4. So let me do that. There's a connection from 2 to 5 and 2 to 4. Next we'll do 5. 5 was connected to nobody. So I'll move on. I'm going to do 4. 4 was only connected to 6. That's done. And 7 wasn't connected to anybody. So we're all done. So notice all of the arrows are number 1 going in the right, well, from one direction, let's put it that way. Number 2, it actually makes more sense, doesn't it? Number 1 really actually starts things off because 6 is dependent on it and 3 is dependent on it. So go figure. Number 1 really is the one that starts things off, not 0. Then we have 3 and then go on from there. Looks like number 5 really has a couple of dependencies of 2 and 3. So there's a lot of neat dependencies, a lot of neat meaning behind the scenes in all of this.